All right. Let me accept that. All right. So as you guys can see, we're going to talk about some Kubernetes platform anti-patterns, and we'll get into what I mean by a platform here in a minute. Let's see, next slide. Yeah, so the kind of like the focus of this presentation is to tell you some Kate's horror stories. Many of these horror stories are definitely of my own making, the anti-patterns. There are some well-known ones, but then I'll kind of give some examples of how I ran into them and made that mistake. It'll be followed up right after that for each one. It's like what I see or what I've used to kind of fix that pattern. That doesn't mean it's the right pattern. It just means it's a pattern that can be used. This is really focused at multi-tenant Kubernetes clusters. So we're talking about really large environments that maybe like 50, 60, 70 nodes of Kubernetes. I wouldn't call that super large. I'd call it mid-size more. But then on top of that, you're going to have lots and lots of dev teams coming to you with all kinds of different questions and patterns and stuff like that. And then finally, I just kind of wanted to throw in a whole bunch of memes, and I had a lot of fun making these. So a little bit about my background. I think I know a lot of people on the call. I worked first in big data doing Hadoop and some MapReduce in Java. Not much of that. I wasn't very good at it, to be honest. And then I found this thing called Apache Pig, and I saw it at OSCON. And they talked about how it was Twitter actually talking about how they were using it to do user analytics. And I thought that was really cool. So I started doing some like scripting on big data. And I thought I was going to go the data scientist route with my career. But then you'll kind of see that I got sucked into running these clusters and orchestration. From there, I kind of saw that Spark was taking off. And I found Spark to be a lot easier to actually go out and write Spark jobs in big data. So I took my Python experience and I started writing some Spark jobs. And eventually I left the government, went private industry. And then in this last job that I've been in for almost 3 years now, I showed up and they're like, you're the Kubernetes guy. So I kind of learned Kubernetes on the fly with the dev team, and I was their DevOps guy. And that was a big hill to climb for me, but it was a lot of fun. So you can see here roles. I started out as an analyst, big data. I learned a lot of orchestration when I was at Decision Lab / Optiv with all you great guys on the call. You taught me a lot. And then I've kind of been focusing more on DevOps, Kubernetes, a lot of Gitlab CI CD. So I love Gitlab. Kind of following the format. The talk is going to follow the format of the Animaniacs. Good idea, bad idea. If you've ever seen that little skit. Yeah, enough said about that. So without much ado, here's our first example. Yeah, I got some good stories about this one. So high level architecture, let's talk about like what you want your clusters to look like. The anti-pattern for this obviously is going to be cramming everything into the same cluster. So some examples of what I've seen are, hey, let's go ahead and run Rancher, and on a Rancher management cluster, let's go ahead and in the same cluster that's running your management node for Kubernetes, which usually rolls out your worker clusters, they're also going to jam in a whole bunch of shared services across the dev teams. Now, this is bad because it basically centralizes everything as a single point of failure. So they were jamming like Jira and GitLab and Confluence and all these other things in there. And it can also cause some really weird things with like resource contention in Kubernetes. And we'll get into that further in the talk. The obvious like fix for that is going to be figuring out how to divvy your clusters up into clusters that have very specific roles. And this is kind of how I view it. This is actually uh, like your cluster architecture can actually be like formalized. This has some like cloud computing stuff for security and how they use a virtual VDMS and VDSS for logging and all that stuff. That's good information to know if you're working in the federal space. But this is how I do it. You'll notice that it's all color coded up here, and then you can actually see that you're going to actually really restrict what your dev teams have access to. You're going to allow them access to the development cluster and some access to your staging cluster to deploy their apps in. And the way I do it is, and I've seen it done, is you give them their own namespaces in Kubernetes so that they're somewhat isolated. Um, when it comes to like running in production and the services cluster that you might be running, for example, your Docker registry, such as Harbor or Nexus or something like that, or your shared services that everybody logs into through your SSO. So your CI CD pipelines in Gitlab or Jenkins, your security scanning tools and suites and stuff like that, that's all going to be isolated. It doesn't have to be in one services cluster. It can be in many services cluster, whatever makes sense, kind of for high availability and uptime. But this is kind of how I view this at high level. This is one of my favorite slides. Yeah. So if you're like really smart, feel free to roll your own Kubernetes like distributions from the raw bits. That's a lot of work, man. I really prefer to use something that's already out there. I like this slide because my coworker who I worked with was very gung ho, and he was like 21, and he would stay up all night, and then he'd show up at stand up at 9:30. He'd be like, yeah, well, I was up playing video games at 2:30, and then I was like, why go to bed? I was like, dude, you just coded for 7 hours. He was like, well, I'll stay until 3 today. No, go home, go to sleep. There's no point. What I'm trying to say is make your life easier and pick the easy, hit that easy button. You know what I mean? If you haven't seen this, this is the CNCF Cloud Native Computing Foundation. This is like their Kubernetes like kind of like options for all of their layers of Kubernetes. Yeah, you could pick one of each of these, for example, like CNI or something like that, and roll your own and have your encrypted weave and pick your own container runtime. But why do that? Someone has already done that for you and made sure that it's up to date and it's interoperable and all that stuff. You're gonna learn a lot doing this, and I'm not saying don't do it, but I'm just saying don't run that in production unless it's your full-time job to cut a release of a Kubernetes version. You probably don't have the time to update the components, test compatibility, cut releases, distribute it, deploy it. Yeah. And one of the examples that I've seen of this is that you have storage classes in Kubernetes. And what happened was one of the customers I was working with, they wanted to, they were in AWS, so their volumes were coming from Elastic Block Store, EBS. So they decided to run Rook Ceph on top of that. Well, when you run Rook Ceph, it kind of adds different layers in. So you'll take an object store, you have block storage, but then on top of that, they have a file store system, and their actual block storage depends on lookups to their metadata store that's shared by everything else. So basically, they're building a tower, kind of like Jenga. And if you pull out any one of those, the entire thing just comes crashing down. You don't have to worry about that. Just use EBS, the raw storage there. Their downtime was literally in the weeks on some of their production clusters. I think it was 10 days was the longest one, but overall, that Rook Ceph implementation just kept on crashing. Don't do that. Geez. Oh, and guys, feel free to interrupt at any time, or if you have any questions about any of this stuff. Yeah, so I'd say choose a well-known Kubernetes distribution. Things that I've worked with just in the last 3 years. I've used EKS. That's what I started with. It's great because it was a managed service. I didn't have to worry about rolling my own management clusters or anything like that. That's all taken care of for you by AWS. I also deployed a whole bunch of Rancher clusters, both on RKE1 and RKE2. That's the two different. They're just moving to RKE2, which is their new distribution right now, and running Rancher on top of that. So Rancher is just kind of like the dashboard and visualization, but the actual like distribution, and it would be RKE1 or RKE2. And then most recently, I work on a dev team with a lot of VMware people, and we're running Tanzu. And so all this stuff is great. It's done for you. Go find a distribution that has a regular release cadence. Take advantage of their security patching, Kubernetes version updates, their cluster creation management features. And my message to you would be, hey, Kubernetes moves fast. Keep up to date. Like, you should have a process that keeps on updating. And I think that's one of our next patterns. I made this meme. I'm very proud of myself. Yeah, I've got some good stories about this. The anti-pattern here, obviously, orchestration. Use orchestration. Just use it. I don't care. Pick one. I'm not going to judge you for which one you pick. You don't want to manage your processes manually across a cluster. You don't want to manually add or take out nodes. The pattern here is to use for all of the things you're going to do on a regular basis, like update your AMIs or do security patching or things like that. You should be able to orchestrate it or automate it. Orchestration is just automation of automation. Yeah, which is good because, for example, we just hit up on these big log4j ones, and it did affect some of our clusters. And we ended up patching all of that stuff. I know that Log4Shell was definitely could be used on Confluence instances, and I know some people actually got hit with ransomware on that kind of stuff. So it's important to kind of like use it and have like a regular release cadence on this stuff. Let's see. So the manual deployments would be the anti-pattern here. I've got a couple of good stories here. The first version is the first story is about this cluster that I was working on, which had no orchestration behind it, but it was kind of legacy, and there was a lot of stasis there, so we didn't try to orchestrate it. And it was, by the time I left, it had nodes that had over 400 days of uptime. So imagine how old the OS is on that, and it hasn't been patched, the kernel. It had a very poor security posture. And that cluster, because all the nodes had been spun up at different times, was actually running 7 different versions of Docker, if you looked at the nodes, which is just makes troubleshooting a nightmare, because you're getting a different version of Docker for your containers on every single different cluster you get into, every different node your pod gets deployed to. So yeah, there's a high amount of toil and just an inability to actually recover. So, okay, let's go to the next slide. Yeah, so yeah, use infrastructure as code. Do some cluster provisioning. Use it for your node refresh, your service configuration, and even your customer onboarding and offboarding. Now, I segregate all of these. I kind of like, in my mind, have them as different, like ground up different things. So cluster provisioning, it will be your first, and then you'd regularly like make a new AMI and roll out your clusters, like re-roll your clusters. And then on top of that, you're going to have your cluster services. So that's going to be things like what do you install inside of that cluster, like Prometheus, your monitoring, Prometheus Grafana, your like ingress controller, Nginx traffic, Contour Envoy, whatever, all that stuff. And then on top of all that stuff, you also have your customer onboarding and offboarding. I'd say APIs are definitely like your friend and that kind of stuff. I could do just a talk about how to use APIs to kind of chain these tools together. All right, so authentication. This is something that I'm really interested to hear what other people are using, because authentication can sometimes be kind of difficult. And I'm specifically going to give an example of service credential propagation, um, and then kind of like how what we're doing now to answer that need. So the problem with dev teams is you're going to have, say you have 20 or 30 dev teams and they all want an S3 bucket. Well, now you need to figure out how to quickly distribute and refresh all of the actual like IAM credentials and create the IAM roles. So if they need to access that, or say they want to access RDS, a database, or something, some other managed service, Kubernetes, the pod needs to have those credentials as an environment variable to actually go and access that kind of stuff. So in one of the first places I worked, they in the dev team as a non-platform person, they would just give us those credentials, but then we have to store them somewhere. So then they're exposed, the credentials are long-lived, they need to be stored somewhere. And it can be a really high amount of toil. So I want to call it that. You might have 15 dev teams, but you have 3 different environments. So dev, staging, prod, and then so now you're up to 45, and they might have 2 services each. So now you have 90 sets of credentials and roles to manage. Well, the answer to this is actually using an automated service to do this. I've used KIAM and currently using Kube.IAM. No, I used Kube.IAM first and currently using KIAM. The new thing out there is IAM roles for service accounts. But this is super cool because what you can do is you can create a role in Kubernetes, and then basically you have a service sitting on the cluster that takes the role that's annotated on the pod and automatically allows that pod to access whatever service is in AWS that is allowed that role. So you might, for example, make a role for S3, and that will automatically be allowed to inherit all the rights to read and write to that S3 bucket, and delete objects or whatever you make of it. So the way we do it currently is we have some CloudFormation that automatically creates the buckets. We just enter the name of the dev team, it automatically creates the buckets, it automatically creates a default role, and then it automatically propagates it into their namespace. And this is where making sure that you have a well thought out standardized naming system across your Kubernetes and AWS environments is really important, because this allows the automation to just happen and really flow. Yeah, so authorization is our next topic. Yeah, so you'll find this a lot. I have, at least, where as soon as you show up, people haven't really thought out onboarding, offboarding, but not only that, if you kind of show that you can do something, people will just start giving you access to things, and that kind of snowballs over time. And before you know it, you've got a whole bunch of people, like 50 people with like admin access to the same GitLab. And that can be very bad, especially if they're disgruntled. So we're going to talk about a few different things here, and this topic is a little bit more in depth. Yeah, so I've actually in my career seen this a few times. One, I believe by accident. So we're going to talk about the unintentional deletion of something. So back when I was working at the government, there was a big Hadoop cluster, and they had like, I think about 200 users at the time. And it was kind of that example where, hey, you're all devs, we're all just here to play. This is a test cluster. But everybody was doing development, and there was no centralized code repository really at the time. A lot of people were just keeping scripts in their home directory. Well, one day an email went out to all the users saying, whoever deleted all of the user accounts, could you please tell us what happened? And the work of like 200 plus people for like months was just gone. Um, so it's really important to put boundaries around your users. And we're going to talk about how this happens. Now let's talk about intentional maliciousness. My wife was actually working at a very small law firm, and the admin was terminated. I believe there was a shouting match of sorts. And on the way out the door, she deleted the entire shared drive that all the attorneys get to work on. No one noticed for a few days, and all their backups either weren't good or were too recent because they only had a few days of backups. So anyone who kept data on that shared drive, that was irretrievably lost. So it does happen. And then unintentional changes to your actual platform. This is really interesting because when you get into orchestrating your services and things like that, there can be byproducts that actually change the way a cluster works. So one example here is one of our devs was just one of our platform people was just trying out a new Helm chart, and that Helm chart, they can install sub Helm charts. And this one automatically grabbed a sub Helm chart for the Nginx ingress, and it hijacked all of the ingresses. So basically all of the DNS resolution for all the apps onto that cluster. And it basically broke everything on that cluster. So we're going to talk about a couple of ways to actually stop that from happening. So this is my view of this, and this is a very rapidly changing landscape. Let's talk about a few of these individually. Kubernetes has objects, and you can create user roles that limit the actual users. I'm going to give an example of that. And then you can actually restrict how objects work. So how much memory and how much CPU when they're already on the cluster. And then you can restrict how they talk to each other. That would be network policies. And then finally, you can actually, with Open Policy Agent Gatekeeper, it's an emission controller, and you can double check what an object is going to look like and validate it. So there's a validating admission webhook or a validating webhook, but there's also now in it a mutating webhook where if you don't like it, you can set rules and you can say, hey, I don't like the type of PVC this is using or the type of storage class, go use this one instead. So you can actually change objects before they run on your system. So this is like a great set of tools and especially to know how they work on a case cluster, because these are really going to help you define how your cluster works overall. And I don't think many people use these things or kind of think how they do it. A lot of people just deploy everybody in namespace and say, go have fun. It's not going to bite you until you start getting into lots of dev teams all contending for the same resources. And at that point, it's almost hard to walk it back and say, hey, you need to define all these other things. Nick, you have a question?
I have a question. While you're mentioning Gatekeeper, I was just wondering if you had ever looked at Kyverno. I haven't used it myself, and I was just wondering if you had done any research on that while you were looking at Gatekeeper.
So the one thing about Gatekeeper, I don't know if it's changed because it's been a minute. I did look at Kyverno and it did have mutating webhooks, and also I like that the language is much easier than I think Gatekeeper uses something called GOML, and honestly, I couldn't grok it very well. I had a hard time. The great thing about Gatekeeper though is that there's a library for the constraints and constraint templates, and you can just literally copy and paste them into your cluster. But that being said, it is kind of like for me, it's a sit down and look at it for a while thing. I don't care which one you run. It looks like Kyverno might be a little bit easier to run. Gatekeeper, it's just been around longer and has more adoption, so there's more examples for it. Just use one is what I would say. Okay. Yeah, so this is actually pretty interesting. I really like talking about that. So like one of your Kubernetes roles, your pattern, this is what they look like. They're actually pretty easy. I made this one to create. I made this one. We're just gonna give you a, I'm just gonna run you through this really quick. So for example, let's see the rules, API groups. What is this one doing? Kubernetes roles. Did I pass? Oh, huh. This is not a Kubernetes role. Oh, this is okay. Sorry. 1 second. Oh yeah, cool. Okay, so what this is saying is, I just put the example role and example namespace to just put an example in there. What this is saying is there's a default API group in Kubernetes, and this API group is the root API group that we're looking at. Now, what I'm saying in here is allow all the verbs for all of these objects. So allow devs to alter their own config maps, endpoints, events, pods. And here's the kicker. They won't tell you if you describe the actions or the different resources. They don't go to the second level. So remember that pods, you'll have to go digging, but pods has a log, an exec, a port forward. If you've done any of those object actions in kubectl, you can actually specify exactly which one of these are allowed in your roles. So be very specific with what you want dev teams to do and not do. Notice that I did not, in this one, allow them to create their own namespace or annotate their namespace, because the annotation on the namespace that we run or create service accounts, the annotations on our namespace kind of ties into what S3 roles they can inherit or, KIAM roles they can inherit. So yeah, so it all ties together. Yeah, here's a Kyverno OPA Gatekeeper example. This is actually one that I really like. I'm not a big fan of running node ports on clusters. So a node port is a service in Kubernetes that will start up a high number port like 3259 or something like that. And it'll open it up on every single node on the cluster. What I would say is funnel all of your traffic instead through a service and then an ingress controller that then goes through some sort of corporate firewall like a Palo Alto, or that can do break inspect, and everything is routed through 443, because then you have one ingress egress for all of your traffic to your cluster. And to actually get access to your cluster, you might open 6443 and then actually or have to go to like a Bastion or a jump box or something like that. So this actually is a constraint template that actually says, hey, you're going to start a node port. I'm sorry, we don't use node ports here. So self-service. So you're on a platform team and you have 15 dev teams and they have 5 people each. All of a sudden you have a lot of users, and your platform team might not be sufficiently staffed to teach everyone Kubernetes. And that's honestly the hardest thing. It's like, how do you get your dev teams to prod from a Devops CI CD perspective without constantly being available and helping people? And one of the things that we found is that this is kind of like a soft qualitative thing. I think there's a lot of right answers here. I think you got to walk that middle line of giving them examples. And then I think that going back a few slides, if you remember all those tools that we can use, you set all of your restraints on what users can do as security mechanisms and not in security policy. I'm a big fan of hey, have you figured out how to go do this thing? I guess we allow it. unless it's malicious, running Bitcoin miner or something like that. And yeah, so you give them the path and you show them the way, and you trust that they're going to do their best to actually go down that path, and you try to put the guardrails up. But then just send them on their way. Let them kind of fumble around, because let's be honest, like that's how I learn, is by making mistakes. So the anti-pattern here is to not give them a path, or be too prescriptive and say, you're just a developer. What do you know about platform? And not show them how to do that. And this can be very, it can be very simple, honestly, for a self-service pattern. So this is something that software factories, which I've worked at a couple of now, kind of try to do. What a software factory is, it gives a developer, development teams, all the basic services they need: GitLab, a CI CD pipeline, a platform to run their stuff in, and it kind of level sets everything across the way. And that might mean that those dev teams come in and they immediately get some sort of security posture because they're running on an accredited system, right? They should have dev teams coming in the door. An ideal way to do it, in my mind, is to have a kind of a well-known path to production. So that's going to be kind of like user instructions on, like, here's how the steps you need to take, the different types of security scanning, the gates that you need to hit to actually get your thing deployed. And with that comes, that are two things that are really super helpful for dev teams, are an example project, especially if they're new to that environment. We do a lot of, in my current instance, we do a lot of Spring Boot, but in the one before that, it was all Python containers, and we were doing microservices processing. So whatever it is, kind of a hello world example, and that hello world example should run you through the entire CI CD process, so that it should build, it should probably unit test, it should have the entire security scanning pipeline in there. It should push it up to a container repository, whatever you're using, be it ECR, Nexus, Docker, Harbor, whatever. And then it should actually go ahead and have an example of how to deploy into dev, and maybe even into staging. And then when that dev team is up and running and they've got their all their Kubernetes objects up and running in that example project, they can see it and they can start playing with all that stuff. And they don't have, it kind of lets them hit the go button and not have to figure out everything themselves, but give them all the working examples to play with. So this is kind of what I've been working on. I've done a lot of the security scanning stuff recently, like Zap and OWASP, and integrated all that stuff. So your self-service examples, if like for an example, if a dev team wants to spin up, I just grabbed this as an example, can actually be really simple. They can just be some bash commands that they can run in like a GitLab CI CD stage. It doesn't have to be really complex. This is 4 lines. It installs Kibana on a Kubernetes cluster. And when you're doing this, try to use variables, lots of variables, and then that way it'll run automatically in their namespace. Yeah, not that example, but yeah. Containers. Everything in Kubernetes is containers, and it's really important to know exactly what container you're running. So I've got, this bit me in the butt recently. So as you can see here, latest is really just a tag and nothing more. I know it's a lot of people run latest. Don't run latest in production is my message to you. You might not even want to run it in your staging, maybe not even in your dev. The anti-pattern here is to use a latest tag in a CI/CD pipeline, in production, wherever. The pattern that we're actually going to go with is using a short SHA or a semantic versioning. Yeah, so the way that this bit me recently is that we had Postgres installed across a whole bunch of, not only for use for our developers for a database, but it was also supporting some of our shared services. Harbor uses Postgres, for example. Well, our orchestration was pinned to a major version, but it was pinned to the major app version in a Helm chart in the values file. You might be internally wincing right now. Well, that app version doesn't really necessarily have to match a Docker major version. So what happened here was we pinned it to 11, and we were running 11.13, but then 11.14 came out, and it turns out that for Postgres, the jump from 13 to 14 is a major version difference. And if you've ever installed a new version of Elasticsearch or Postgres, the very first thing that happens is that the database goes and updates the schema across all the databases and on all your data for you. And it's not a rewindable situation in many cases. This caused our Harbor to go down, which is kind of the lifeblood of Kubernetes, because that's where it pulls Docker containers from, and it caused a significant outage. Boy, we learned a lesson. Don't just pin it to a major version. Make sure you're actually pinning it to a version that actually is followed by that thing. Pin it to a major, minor, even a maintenance version. Don't deploy .zeros. Wait until the service pack, and yeah. So the pattern here is actually in your CI CD pipelines. You can use GitLab CI CDs. These are automatically generated for you, the variables. Jenkins has it too. I looked it up really quick. And what you do is, for example, if you're doing a build, say you push to a dev branch and you're using branches. So dev branch commits the dev cluster staging to staging and prod to prod. What you can actually do is dev will commit, it'll build that image, it will give you this short SHA. You push to Harbor using that short SHA, and then in your pipeline as you deploy, you just keep using that short SHA all the way down until you deploy, and in your Kubernetes templating, you use that same short SHA. Now you're guaranteed to be deploying the exact version that you want that got written into your Docker registry. So this is really powerful. There's no questions whatsoever about it. It's verifiable, and that's kind of an example. So it could be nginx : da 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 da. You can do semantic versioning too and use tags. Nothing wrong with that. But a tag doesn't guarantee a specific image. Nick.
Hey man, so that sounds like it would be super useful for things that you build, right? But as far as maybe having like external containers, like you said, Postgres, I've been trying to find somebody that actually uses this because I haven't had a chance to like try and integrate it. But have you looked into KBLD or KBuild, I guess, if you want to use a word for it, for like pinning based upon semantic version and not having to like look up the actual SHA?
In short, no. We are using Kpak right now, and we're about to start exploring using a system that would guarantee a specific version. Let me get back to you on that. I'm blanking right now, but yeah, we should talk about that.
Yeah, this is a Drew Malone special. He was the one that pointed me at Carvel in general, and it's one of the suite of tools, right? Like the K14S stuff.
Yeah, we're actually using the Kpak and KBuild stuff right now, and I believe it does that under the hood because we're using Tanzu build service, which is just Kpak. I don't know enough about it to speak intelligently on it. This is my favorite meme so far. So container scheduling in Kubernetes, you're gonna get some odd things happening, especially when you get a ton of people on your clusters. And if you don't have auto scaling on your clusters, which means it adds nodes on demand, you can get some funny things happening. Sometimes it'll just jam stuff in there. And the anti-pattern here is just to assume that pods know how many resources, by resources specifically, I mean CPU and RAM, that they need. The pattern is to, across the board, enforce the very, in a declarative way on every single deployment, that every pod knows exactly how many resources it's allowed to use. Let's talk about resources, requests, and limits a little bit. I'll tell the story first.
Boom.
So I managed to crash, I think, a couple of Kubernetes clusters using Elasticsearch of all things. Now, how did this happen? So we had, imagine a small cluster. I think it was like 12 nodes at the time, 12 worker nodes at the time. Each worker node had was an instance that had like 16 gigabytes of RAM. Well, they were already provisioned at a pretty high level. Say that they were up at like 12 to 14 gigabytes of RAM, and we did not have auto scaling on this cluster. None of those instances had requests or limits. Now, imagine this, that you have the actual, you run top on a node and it has 16 gigabytes total, but you're using 14 already. Well, my pod got assigned to that node for Elasticsearch, and I had declared for the JVM, say 6 gigabytes, something not out of the realm of, it made sense for Elasticsearch. Well, immediately, what happens to an EC2 node once you over provision memory? It crashes. And then the Kubernetes cluster, being the good Kubernetes cluster it was, took my pod, my Elasticsearch pod, and moved it to the next provisioned node that didn't have enough room on it. And that node crashed. And then the next node crashed. And then the next node, you get the idea. If your pods are all deployed without resource requests, Kubernetes will just throw it in there and it will not reserve the memory that it needs. And you can crash out EC2 nodes by over allocating RAM on clusters. This does not do good things for your uptime on clusters. There's a solution to that. Go next. And that's to actually set limit ranges on everything. There's two different ways to do this. And then there's actually a third way I'm going to talk about really quickly. Limit ranges are kind of like the min-max CPU and memory that are going to be on a pod. So you can set on each namespace as you create it for each dev team, you can automatically say, here's your default for each pod entering the system. I don't think this is a great answer, but at least in development, it allows dev teams to get used to the idea of, hey, I need to set these things on each deployment. Now we're going to talk about this for a second. So say for a second, you're running something that runs kind of heavy. Say you're doing like PDF processing and it needs 2 gigabytes of memory. Your default limit range says each pod can only have 1 gigabyte of memory. As soon as your pod starts allocating more memory, Kubernetes for memory will just kill that pod. So it'll keep killing it as it hits more memory usage. For CPU, Kubernetes natively just throttles. So it'll just slow you down on your usage. It's important to kind of set like, here are your normal boundaries. for pods, and then make sure that devs actually set those. Now, how do we make sure that devs actually set those? You can just write an OPA gatekeeper rule or Kyverno rule that says don't allow pods to run unless they have requests and limits set. So that's one thing that I did do. And I think it really makes sure that everything in the cluster is labeled. And then what that really works nicely with is if something comes up and it needs too much, well, that node will be like, hey, I've already reserved all this. You don't fit on this node. Your auto scaling will automatically go provision a new node for it, and it'll go live on there. So you won't have this resource contention with clusters just crashing. One other thing you can do is you can set per namespace or dev team. You can just give them a strong limit around everything and say, you can't use more than these resources. Come talk to us if you need something else. And what this really does is it forces developers, especially if they have native access to their namespace, it forces them to clean up all their old instances of databases and test pods and stuff like that. Well, that's it. That's the last anti-pattern. If you guys have any questions, I'd love to hear them. If you have any comments on other things that you've used, I'd love to hear that too, because like I said, this is how I've wrecked things. I'd love to hear some of your horror stories.
People are just being shy.
Hey, Justin, Aaron here. I learned the hard way with the resource limits via 2,000 restarts for a pod that they matter. You're right.
They really do, and not many people. It's not on many people's radar until they actually go through the pain themselves. Nick, I'm trying to look up your that thing I was talking about. Maybe Drew knows. Hey, Drew, is there an automated deployment technology that Carvel has?
I think it depends on what we mean by exactly what we mean by automated. Like to me, that's a CI CD plus cap. Certainly Kbuild is part of that, like packaging and creating like the manifests that point to your images, right?
Yeah, I think there's an automated thing coming down the pipe with the new tap.
Right.
That's open source. I'll find it. I'll get back to you, Nick.
Speaking of open source and VMware stuff, a little bit off topic, but has anybody looked at or actually running the community version of Tanzuno?
For TCE, you mean? I think they're coming. I work with enough VMware people that I can kind of speak to that. There's another cut coming within the next few weeks that's going to answer some of the problems, but they know that kind of like self-starting it up is an issue right now. I haven't seen, I tried to look into the versions for it, and I haven't seen that they've actually hit like a release cadence where like they're patching things on a regular basis as an internal team for it to actually be stable enough to use. So I don't think anyone's using it. I think it's just like, hey, download it, throw it on your MacBook or whatever, AWS, but I don't think anyone's running it. I haven't heard of anyone running it in production.
Yeah, it is. Say again?
I was just gonna say that I saw the release of it, and then that was pretty much it. I did see like somebody put a blog out like, hey, So I spun this up for funds, but that was about it.
Yeah, I
Yeah,
tried to
it's
spin it up on my MacBook and it just died on me. And I wasn't gonna spend the time to troubleshoot. Why the management cluster wasn't coming up, so I was like, yeah.
yeah, it's still in its infancy, and like Justin commented, it's the ability to run the Kubernetes platform like on a laptop is going under a refactor right now. They're changing out the tech under the hood to acknowledge and to fix a lot of the problems that have come up with that. But yeah, it is still it's still in the beginnings, so I certainly wouldn't expect to see anyone running in production just yet. Any other thoughts or comments, or even war stories for Justin?
Question about why do you care about the limits min memory? Ooh, that's a good question. So when you set the requests would be the min memory. That's what does the actual reservation. You guys correct me if I'm wrong, someone. But that's I think what actually sets the actual reservation. So you probably want to set your min memory somewhere close to what your pod is actually going to use. Also, look into if you're going to do horizontal pod auto scaling, that's based off of CPU. But if you're gonna base it off of, for example, your request for your CPU, that's actually based off that, I think. But yeah, so you want to make sure your request is high enough that it actually reserves memory on the node. So then you don't end up getting assigned a ton of pods that then crash it out.
Just a curious question. One of the things that you said was, like picking a Kubernetes distro that is out there instead of rolling your own, right? It's looked like a lot of what you're dealing with is in AWS. Are you using EKS or are you running your own on top of IaaS stuff?
We did, so the three different things we did was three different ways of deploying it actually. So I did run EKS through, let me figure out if I can get the versions right. This was like almost 3 years ago now. So I think 1.11, 1.12, 1.13. And I actually, we actually did the upgrade process. I used a little script called EKS Cuddle at the time. It was very hacky, but it was a fast smash button, and we got our dev team up and running pretty quick. It was cool because it like made the VPC for you and did all that stuff. That was the first way I did it. I was running EKS, the managed one. I liked it. It was kind of interesting. It didn't give you a lot of the add-ons at the time where it would like install the ingress controller or do stuff for you. I haven't used EKS recently. I don't know what it does now, but it was had a lot of additional steps that I had to do or needed to orchestrate. The next one that we did was Rancher, RKE1, and then we moved to RKE2. That was all with Terraform, and Rancher has a great startup that you can go download the Terraform module and you can get off and going in AWS on it goes straight in and it deploys EC2 nodes and you deploy a management cluster. And then you deploy a whole bunch of dev worker clusters that sync to that management cluster. It gives you a Rancher GUI. You can go and choose the cluster, view all the workloads. That's a whole nother presentation. That, dashboards and stuff like that. And then the third way that we're doing it right now is we're actually using native Carvel tools, K14s, just across the board. It's massive YCC templating, running cap controller to automatically deploy GitLab repos and run the configurations. And then once those clusters are actually stood up using something called Kpak, which is I'm going to butcher this. It's like the cloud something access provider, AWS or something like that. That's what actually interfaces with AWS. and runs from the management cluster and actually creates all the AWS objects. Once that cluster is stood up, it then loads all of the services. We image package everything. And then an image package installs all of the other services, like we're using Contour, Envoy, Prometheus, Grafana with Thanos for distributed metrics monitoring across clusters. All the additional stuff is doing that way. So 3 different methods of orchestration, 3 different technologies, and 3 different kind of like distributions. I think that answers your question.
Absolutely, thank you.
I have a question going back to the continuous delivery that we were talking about a second ago. Has anybody used something called Flux with GitHub to do that?
Not yet. I haven't gotten into Flux or Argo or anything like that. I'd love to hear if anyone else has.
We're starting to explore it right now, but I didn't know if anyone had any experience with it. But we're just getting started with automating our deployments and updating and relaunching of containers with it.
Did you hear that Flux or Argo? I'm not sure which. They were both kind of based. I thought they were based on the same thing, but maybe there was some licensing decisions that Flux made to not go CNCF with, or I just heard this.
Flux is CNCF.
Okay.
It's one of the reasons we decided to move forward with them, because we're trying to stick with things within that ecosystem.
Like I view the 3 major players, and really only 2 of them are major, as like Argo and Flux being sort of the major ones, and then like Kap's out there. And like Kap has utility because it's pretty small and lightweight and like still does the GitOps job. And then Argo has the more robust UI from what I can tell of Flux and Argo. So that sort of like left Flux in this middle space. So I've never really looked at it, but I mean, the whole paradigm is like really awesome. I'm a big fan of it. And Argo has worked mostly well for what we've needed it for.
Have you used Argo before, Nick?
Yep.
Okay. Is that the one you would recommend over Flux, or?
Like I said, I never really like got too hard into Flux, so it's not like I've done an assessment and said, oh yeah, Flux sucks, I'm going to do something else.
Oh no, no worries. Yeah, I was just wondering.
Yeah, it was more like
if we're starting to go down the wrong road. Like.
Yeah, if my really high level assessment is if you have developers that you're expecting to be inside of UI and like do stuff, Argo might be the better pull, so you might want to look at it at least.
Okay.
Because the UI does seem like it gets a lot more love than the Flux UI.
Gotcha. Cool. Thank you.
There was one question about how do you decide how to max memory CPU to give to a pod? A lot of this, I think it depends if you're coming at it from a developer standpoint or a platform standpoint, or you can run vertical pod autoscaling, which I have not done, to automatically recalculate what that needs to be. But definitely from my experience running, like we were doing like 20 or 30 different deployments into a namespace and using microservices stuff, it was just a lot of observation and tweaking. We would kind of have a base set, and then we knew that some of our stuff was heavier. And then for the max on our RAM, we would go a little bit higher, so we would know. We weren't using JVM, so it was all Python. We would see if anything was crashing out. It was a lot of experimentation. I don't think there's a silver bullet there, not that I know of. Something that can really help you with that is monitoring. If you can just make a long-term graph of Prometheus of your stuff that's running in your pod, and what resources it's using, that'll give you a baseline pretty quickly.
Another question for you. I don't know if you, I came in late, so I wasn't sure. But for my deployments, at least, a problem with, because I have the resources, the YAML files, and then I needed to replace, different values in the YAML files based on the environment that I'm deploying to. So I was wondering how you do that. I just ended up having to create new YAML files and appending replace to them. I forget exactly what bash utility I did to do that, but it's just a real pain to keep up. And I was wondering how you did that sort of thing.
Yeah, that's a great question. There's lots of different ways to do it. Usually you're going to have a templating tool of some sort. Carvel has this thing called YTT, shameless plug for Carvel. I found it to be a bit complex, but you can also do it with Customize, which comes with kubectl or something like that. So basically what you do is you write your base scaffolding for your Kubernetes object and say you have a pod. Not much is going to change. Assume your environments are all the same. That's a great thing about orchestration. You should all have the same name for all your storage classes and stuff like that. So none of that will change, but maybe you have like an environment variable that you need to change in each one, right? And you don't want to write all three YAML. So what you would do is you would use your templating to write an overlay, which will change it. And then I'm assuming you're using CI CD and you're deployed to dev, you would call with that overlay, and that would change inside of the YAML versus the staging versus the prod. When I started my Kubernetes journey 3 years ago, we were literally just doing sed commands on that same template across environments. Not the best. And then we went to customize, and then we went to Helm charts, and now I'm using YTT to do that kind of thing. So automatically generate it. But this also kind of goes back into make sure that you're tying in as many variables like from your GitLab CI CD. So like that CI commit short shot, so that they all get automatically inherited into your deployments. So you can change fewer things. Yeah, but yeah, a templating language.
I'll throw my my weight behind YTT if it's really complex what you're trying to do, because it is like super powerful. I ended up writing this like weird YTT template that combined with vendor to like pull down an external Git repo and like iterate over top of files inside of it. It was pretty crazy, but you can do stuff like that with YTT just because it allows for so much. But if you need something simpler, it might be, like trying to use a nuclear missile as a hammer, right? Like pretty crazy.
Yeah, like for example, it could even be a bash script that you had, like if you're doing a Helm deployment across 3 different things, and that you just use a set variable in your script, or in your CI, you just change a variable and that gets ran inside the runner. It just calls that variable and picks that up and then runs it, But yeah, templating languages for if it's straight Kubernetes objects. Interestingly enough, I've seen devs use Maven templating, Docker mustache templating, sed, bash scripts, all kinds of things to do this. But I do find that customized Helm and YTT are by far like the most Kubernetes native, ways to do it.
Take a look. Thank you very much.
Hey, this is Lavanya. I joined a little late. I have a question regarding the EKS upgrades. like say for example, if I'm on a version of 1.18 and I want to upgrade to 1.21, so what is the best practice when we upgrade, do this upgrades? Like, is it with minimal downtime in production? Right now, the way we are doing is like we are setting up a new cluster with the latest version, and then we again deploy all the changes over there, and then do a CNAME switch to that particular cluster. Do you think this is the best way to do it? But this is adding cost to the customer.
I'm gonna hit phone a friend on that one. I haven't touched EKS since like 1.13. And I found the upgrades to be highly manual at the time.
So EKS can manage all that stuff itself now. Like if you say, hey, I want to go to the next one, it can roll that out node by node inside of your cluster so that you don't really have much downtime and you're only incurring the cost of a new instance until it fully takes over its node capabilities. So I would definitely advocate for not doing it the way that you're doing it and trying to use the EKS native upgrade capability.
Okay. Thank you.
Cartographer, Nick, it just came to me. I don't know if you've heard of that, but it's just as Kpak is to automatically build, Cartographer is to automatically deploy.
Gotcha.
Yeah, I should have known that one. Justin, I think you tired out the crew. Is any other anything else from the room?
This was a great talk, guys. Drew, are you going to be sending out the slides to this?
We can post these.
This was awesome. No, thank you, guys.
Yeah, definitely. I heard Justin's coming back for the next 3 talks. Is there any truth to that rumor?
I had fun. I might do this again sometime. Drew's been asking me for like 2 years.
Yeah, like Judy said, we'll post the recording as well as the slides for sure. I think Justin's already set himself up for like 2 more of these.